Hey, welcome back to Math with Patrick. It's April 3rd, and let's solve the 93rd problem from this Daily Epsilon calendar. When we don't have any instructions, you can assume just to solve for x. And we're supposed to show that x is going to be 3 today. Looks like we have a system of equations. This first one has some variables squared. This next one has it looks like a linear equation to me. As in, like, if you graphed this one, it would be like a straight line somewhere. I think the slope would be actually negative on this one. And then this one looks to me kind of like actually like a hyperbola. I know that doing x squared minus y squared equals something is going to produce a shape that looks like that, or maybe it looks like that on the graph. And so let's just see what the algebra says, and then why not we could go check out Desmos after trying the algebra. I see something called a difference of squares. Whenever you have two square numbers and they're being subtracted from each other, there is a way to factor them. I know it's going to be 2x minus y and then 2x plus y. Just to kind of prove why this is the case, if you redistribute these binomials, you can multiply the two first terms together, then the outside terms, and then the inside term, so there'll be a minus 2xy, and then finally the last terms together, so minus y squared. And this plus 2xy and minus 2xy are going to cancel out, leaving you with just that 4x squared and that minus y squared, basically where we were at the start of the problem. And then we can use some substitution. The second equation tells us that 2x plus y is just the number 5. So I can take this whole factor and change it to 5 and keep everything else in my equation the same. Seeing this, something times 5 is 35. Well, I know that 2x minus y is going to be 7. Now, I'd really like to, solve for x and figure out what just the x is. And I think what I could do now is hold these two equations up to each other. And if you can just kind of think about how this side is the same as this one, and this side is the same as this one, if I add the left sides and add the right sides, my equations should stay balanced. This is a strategy called elimination, where by adding one equation to the other, we're going to eliminate or get rid of one of the two variables. So 2x plus 2x is 4x. Negative y plus positive y is 0. It's eliminated. And we're left with 7 plus 5 on the left side. Now, 4 times what is 12? Clearly, that missing number is just a 3. So we're done. That's today's date. Just for kicks, why not? Let's figure out what y is going to be. You could plug this 3 back in to any of the equations we were using. I think this 2 times x plus y is going to be the easiest. And I see 6 plus y is 5. And just, knowing like fact families, well, 6 minus 1 is 5. So this shows me that y has to be negative 1. And it looks like that's my one and only solution. So x is 3. That's today's date. Y is negative 1. I'm just curious to see what this looks like on a graph. So let's hop on over there for a sec. The first equation was 4x squared minus y squared equals 35. And here's that hyperbola shape I was talking about. If you zoom out really far, it just basically looks like the letter x. But when you zoom in, you have this interesting feature where they don't actually touch in the middle. And then the other one we had was 2x plus y is 5. And here is that straight line. Now, for most hyperbola and line systems, you're going to have two solutions. And you can find solutions by looking for intersections between curves. And so for most other lines and hyperbolas, you have one solution over here, one solution over here. I guess I could be a little bit clever and make like a vertical line. And then here I still have two solutions because there's one intersection up here and one intersection down here. Though there are these kind of niche scenarios where you might have 1 or 0 solutions. So like if I just bring in my x a little bit more, this would be a 0 solutions example, just because there's no intersections on the graph. Also, if you tried to like plug in this 2 right here, you'd essentially get this like weird result and you wouldn't be able to solve for y. And that's another way to kind of figure out how many solutions you have, is to do the algebra for it, which is kind of what we did a few minutes ago. Anyways, back to the original problem. If you kind of look around, these lines essentially look parallel and they're really never going to intersect that way. And if you go over here, it looks like we have one and only one intersection point, and it's going to be when x is 3 and y is -1. And so those are the values we saw on that kind of whiteboard page, and this graph kind of confirms the solution that x is 3, y is -1. So we're all done. Thanks for confirming and solving this with me. And I guess I'll see you tomorrow. Alrighty, bye.